Hi, today I'd like to start by trying to sketch the following functions on a graph. So pause the video and have a go at that. If you're really not sure what to do, then hold on and I'll give you a few hints. So some hints are that you need to be able to plot the graph, you need to find what kind of shape it is. So is it a happy quadratic or a sad quadratic in the case of these quadratics? You also need to find the y-intercept. What happens when x is 0? And then the third thing is what happens when y is 0. These are called the roots of the equation. They're where the graph crosses the x-axis. If you can get those things, then you can get a decent sketch. The added extras, you could find the turning point because the turning point is always halfway between the roots. And there's a line of symmetry going down between those two roots. Okay, how did you get on? Well, the first one can be factorized as x plus 3, x plus 4. Two numbers that multiply to give 12 and add to give 7. That's the way of doing this. That gives us solutions. That gives us a happy quadratic, and it gives us a y-intercept of 12, which I've added, and then the solutions for when y is 0 are minus 3 and minus 4. Next one turns out to have, we call it a repeated root. So it's just x plus 1 all squared. And that means it just touches and goes back up at minus 1. And the y-intercept is 1, and again, it's a happy quadratic. C, another happy quadratic. This time, there's no common factor, so you have to factorize it, and you get 2x plus 3, x plus 4. You have to find a way of making that work. We get a happy quadratic. We get that it crosses the axis at 12, and then it's going to be minus 3 over 2 and minus 4 are going to be our roots. C, this is a difference of two squares. You could write this as 4x all squared minus 5 squared, and hence factorize it as 4x plus 5, 4x minus 5. And that gives us another happy quadratic. It gives us a y-intercept of minus 25 and roots of minus 5 over 4 and 5 over 4. The last one is my challenge question, and it's not quadratic at all. It's an x to the 5 equation. So a bit like a cubic goes like this. Not always, actually. Like x cubed itself just looks like that. But this would be a quintic. It would maybe look like this. Whoops, that didn't come out right. So the main thing is, I think, is to find the y-intercept as normal, which we can see as 0 because there is no constant. But you can factorize it to get the roots, and if you do that, you'll find it factorizes like this. You'll take out an x, and then there'll be you can take out an x squared minus 1 and an x squared minus 3. Anyway, that's how you factorize it. And then if you follow sort of my little description there, it goes through minus 3, back down at minus 1, back up at 0, back down at 1, back up at 3. Okay, as I said, that's my challenge question, but you will be expected to potentially draw graphs like that, but we'll do more detail on that another time.
Today's lesson is on completing the square. You may or may not already be familiar with this. If you are, there should be some things in here that you're not familiar with, and it's still useful revision. If you're not, then I am teaching it from scratch. I'm just doing it maybe at A-level pace, so sort of quite fast. But you've got a video to watch, you can re-watch it, and you can get your head around it. It's a really useful method. It might not appear so at first, but I'm going to try and bring in aspects, and we're going to be using it in subsequent lessons as well. So just to start with, to let you know, there's a period of maths called Babylonian mathematics. The Babylonians were a civilization, one of the first in the world, beginning perhaps around 4,500 BC. That's 6,500 years ago. And they existed for thousands of years, and they practiced maths as any civilization that's trying to develop does do to just out of curiosity and also because it has many applications. And one thing that they've discovered is a neat way of investigating quadratics called completing the square, and I'm going to explain exactly why it's called completing the square. So let's say I've got the expression x squared plus 4x. I could represent it visually as a compound area, essentially. I've got a square on the left, and I've got a rectangle with dimensions 4 and x on the right, And if I find the areas, I'd get x squared plus 4x. Right, nothing strange about that. Now, I could start representing it in a different way, however. I could split that 4 into 2, to 2 and 2, and I've got exactly the same area here. And then I could do something pretty neat. I could take this rectangle and move it, turn it, and put it right down here. And what I end up with is something that is a shape that's now x plus 2 in length, and it's x plus 2 in height, because remember, this was 2, and I turned it, so that is also 2, so I've added it there. And what this gives is nearly a square of dimensions x plus 2 times x plus 2, or x plus 2 squared, i.e. I've tried to complete a square. The only thing is I've got this missing bit, this blue bit here, and that has an area of 4, so I need to subtract it. And so overall, I can show that x squared plus 4x is equal to x plus 2 all squared minus 4. Why on earth would I want to do that? Well, two reasons. The first reason, which I'll talk about the turning point in a minute. The first reason is that I've actually managed, I had an x and an x, and I've managed to make it so I've just got a single x. I know it's in a bracket and it's being squared. That's always the key to solving equations. You want to, you don't want loads of x's in your equations. You just want to get down to what x is by itself. That's going to be useful. The reason we're going to look at today is actually it tells us about the turning point of this graph. Because when we look at it, if I'm squaring something, if it's negative, it becomes positive. So minus 3 all squared is 9. And if it's positive, it remains positive. And if it's 0, it stays as 0. But the point is that this thing here is always greater or equal to 0. It cannot ever be negative. And so I might be interested in finding the smallest possible value of x squared plus 4x. And that is going to be minus 4. The turning point is going to be when y is equal to minus 4. It can't get any less than that, because how can it be minus 5? Because there's no way I could get that. And then what is the value of x, which gives me the minus 4? Well, it's going to be when this bracket is equal to 0, when x plus 2 is equal to 0, or when x is equal to minus 2. And what we can then write down is the turning point. It's a different way of finding the turning point. I have spoken about another way, like finding the roots and then finding the midpoint. There's going to be graphs that don't have any roots though, and so completing the square comes into its own here. And you don't need that other method either. You can just use this one if you want to. So we've used geometry to complete the square and understand it, and then I've just spoken about how we can find the turning point. Hopefully that makes sense. What I'd like to do is try this one yourselves. Can you complete the square on x squared plus 6x, thinking about it graphically, and can you write down the turning point? Go. So we're going to do exactly the same. We've constructed this geometrically. I'm going to split the 6 into 2 parts, 3 and 3. And then what I'm going to do is I'm going to take this 3 bit and I'm going to move it down and turn it, and suddenly it becomes the thing on the right. It's going to have these dimensions, 3 and 3. So it's going to be x plus 3 squared. But again, I've got this missing bit that I'm going to need to subtract. I'm going to need to subtract 9. Now the aim for this lesson is to be able to go from here to the right hand side without using the graphical picture, but the graphical picture I think helps in the first instance. And the turning point is then going to be, the smallest value is going to be minus 9. In this case that's a minimum, but we're just focusing on turning point. Turning point, maybe I didn't say enough about this. It's going to be this or this. We're mainly focusing on minimums today. And then the graph is going to be bigger than minus 9 everywhere else. And what makes it minus 9 is going to be when x is minus 3. So we've completed the square on x squared plus 6x, and we found the turning point. Good going. Right, I want you to try this one yourselves. Notice I'm like slowly taking away, this is called scaffolding, I'm slowly taking away bits of it to make you think about it. So exactly the same process again. I'm going to split the 5, because I don't want to split the x up. I've already got a square here. That's really good. I'm going to split it into 5 and 5. I'm going to move this down. So you should have drawn something similar to what I've now got. Okay, I'm not going to draw it on the right, but that should be what you have. So this becomes 5 here. And what am I left with? I'm left with x plus 5 squared. I've completed a square. I just need to subtract this little blue area, which is 25. The turning point is going to be when x is minus 5. Look, you can see it speeding up if we've got our understanding, and y is minus 25. That's going to be the minimum points, minus 25, and it's going to be when x is minus 5. Okay, I think we're nearly getting there. Like, try this one. And again, removing a little bit from it. All right, so next bit, freehand this time. So we're going to get x and x. I'm going to split it up into 8 and 8, but I'm going to move that 8 one around to here. And so I'm going to get x plus 8 squared, but then I need to subtract this blue area, minus 64. We have completed the square. These two things are equivalent. Of course, you could expand this out and see that you get back to it. You're going to get x squared plus 16x plus 64. So now you can see that why you have to minus the 64. Turning point, minus 8, minus 64. All right, how about this one then? What if I said instead of 16 or 10, I've got x squared plus bx? See if you can work it out. This is called a generalization. Can we complete the square on this general thing here? It's not the most general, but it's more general. So same idea. X, x. This time, I don't have a nice whole, well, it could be a nice whole number. I don't know what b is. I'm going to have to split it into 2 there. It's going to become b over 2. I'm going to get another b over 2, but I'm going to move that round to here, just like we did before. And we've managed to get x plus b over 2 all squared. And now I'm finding this little blue area, which is going to be b over 2 times b over 2, or b over 2 all squared. And that is going to be b squared over 4, just multiplying those fractions. So we've completed the square on a more general case. The turning point is going to be when x is minus b over 2 and when y is minus b squared over 4. Brilliant. Okay, and what you hopefully noticed then is that every single time, whatever, like x squared is by itself, we just put that in the bracket. Whatever the coefficient is, the number in front of the x, we basically put it inside the bracket and we halve it. And the reason we halve it is because of this geometrical process. Well, I think it helps to understand it. So when it was 10, it became 5 inside the bracket. And then what we end up doing is minusing that thing squared, because that's the missing square that you have. You can see we do it in the general case. We halve the b to get b over 2. We square the whole thing, and then we minus b over 2 all squared. So that is what you need to learn how to do every single time. But what I've tried to demonstrate here is why. Why do we do it? Why does it work? And that comes with time to fully understand it, but hopefully you're happy enough. And the fact that we can get the turning point, I've gone through that a few times here. So I can literally draw this graph. I don't know where the roots are, but I can say that that is the turning point with absolute certainty. And with the numbers, the same thing. Right, I'm going to give you a full example now. Write y equals x squared plus 6x minus 4 in completed square form, and hence write down its turning point. This is actually a sort of question you would see in GCSE. In fact, but it's doing exactly what we did before. We just need to be a bit careful with that -4, but I'm going to talk you through it. So here goes. This is what we're going to remove the pictures now from it. You can always look back at them to try and understand it. So what we're going to do when we complete the square is we've got our x. By the way, I didn't say this. Forget about the -4 to begin with. Just deal with that x squared plus 6x in the same way that we did up here. Okay, don't worry that there's a number after it. That's absolutely fine, actually. We're just going to need to put that in at the end. So completing the square essentially on x squared plus 6x. And that's going to be x plus 3 all squared. Let me just write that 3 a little bit better, because that's us kind of splitting the 6 into 2 and then moving it down. And then I need to minus 9, because that is 3 squared. That's the missing bit in the square. But now I bring back that -4, okay? It's still there. It's just that I've got to take that into account right at the end. So I've completed the square. It's going to be x plus 3 all squared minus 13. We've completed the square. We see that this is greater or equal to 0. So the turning point equals, it's going to be minus 13 when x is minus 3. So hopefully you're happy with that. Try the one on the right. Now, this is a little bit harsh on me because I've not covered a negative, but perhaps you've had a good go at it. And if you're not sure, I'm going to talk about it now. So it's, you can use the graphical pictures for negatives as well. It just seems like the graphical picture gives a good demonstration, and then we leave it. Of course, the Babylonians used the graphical picture because they didn't even have algebra in the way that we do. So they were thinking about it from that perspective, which helped them, and I've introduced it that way. It's actually the same thing. This time, we still have it. We just have -6 squared. Kind of moving away from the picture here, but you can use one. But that's going to give me, if we actually expanded this out, it would give me x squared minus 6x, but then it would be plus 9. And actually, I still have to minus 9 here. So the negative actually doesn't really mess anything up. You just stick it in because there's a negative there. You still do exactly the same process as we did for the left-hand one. This time we still need to add the plus 12, of course. And we've nearly completed the square. We just need to simplify this. X minus 3 squared plus 3. So don't worry about the negatives, just go with it. If you expanded this thing out here, you would get exactly the same thing as that. Still looking at a minimum, this is greater or equal to 0. For it to be a maximum, you'd have a minus there. It would be a sad quadratic to start with, but that's for another day. Turning points, I'm just going to write TP, is going to be 3 this time, and then 3 for the y coordinates. Right, over to you then. I've done a load of examples geometrically. I've done 2 examples of which you hopefully tried the second one yourselves to get complete the square and find a turning point. I've shown an example here of what I want to see from you. So we've got a quadratic. What you would do is you have the 4, you put it inside the bracket, you square it. I hope that makes sense. And you have to minus 4 because you get extra 4 from the square, which you need to take away. And then we're still having to add the 5. That's an intermediate step. And then we simplify it, and then we get the turning point. So can you have a go at all of these questions, see if you can complete the square and all of them, be confident, just go with it. And there's some that are quite interesting where I give you the turning point and ask you to get back to the original quadratic or completed square form. Okay, pause the video, try this out. I'm going to show you the answers. So, just going to talk through them, I think. Very similar for the second one, it's just instead of adding 5, we're minusing 3. We get a different turning point, it's in the same x coordinate. Here, halve the 10, we've got 5, you need to minus 25, still minus the 3. These are very similar to the ones done in the examples, so I'm not going to talk about them briefly. x squared minus 8x is back to like we did at the start. There is no intermediate step. We just go straight to completed square form. These ones, hopefully you're happy with them. You can get -1 and +1, and then you minus those things squared, which are just 1 in both cases, and then you add your 5 turning points here. Similar here. All right, when you have 3, 2, hopefully, I mean, you might not have realized this, but I'm going for it now. So when you have completed square form, you get the x coordinate and the y coordinate. If you have the x and y coordinate, you can go back to completed square form. The minimum value is going to be 2, and it's going to be when x is x is 3, but that means we need to put a -3 in here. So be aware of that. Obviously, in maths, we can go from completed square form to the turning point, but we can also go from the turning point to completed square form. So hopefully you're happy with that, and then we can expand it out, in fact, and get the quadratic to start with. For this one, very similar. I just chucked it in because this time that the y coordinate is 0, so it would just be a +0 here, which you can just leave off, and it's simply x squared plus 4x plus 4. Okay, these last three just make it a little bit trickier. What if there's a fraction? What if there's a number that doesn't divide nicely by 2? Sorry, you just have to roll with it. Okay, it's 3/2. It's the same thing. And then you minus 3/2 squared plus 20. Yes, you're going to get some horrible numbers. You tend not to get stuff like this in A-level papers, but I'm not saying it won't happen, and you should still become familiar with it. I think I have seen it. I forget. Finally, we're generalizing. If you've got 2a, then it just becomes x plus a all squared minus a squared plus c. You can write that down. And I've done a general case for when we got a minus b. I did it earlier with a plus b. It's very, very similar. Okay, and we get this as the answer. So I hope you are happy with that. If not, find some more to practice. You can get there. Look back over my explanation at the beginning for how we complete the square. Hopefully you're completing the squares in a good place. We're not quite finished. We're going to bring a few things together now. So if I have a quadratic, we can now do lots of things. We can factorize, we can find the intercepts, we can find the turning point, and we can sketch it. So we're going to have a go at that now. If you're feeling confident already, pause the video, try this out. Otherwise, I'm going to go and talk through it. So this one here is going to factorize. It's going to become, right, I'm going to have an x here and an x here. I can see 5 and 3 are going to work, so it's going to become +5 and -3. That's factorized. The intercept, actually, I'm going to jump to the intercepts. I'm going to get the y-intercept, which is -15. And the x-intercepts, I'm going to get -5 and +3. That wasn't a very clear 3 there. Sorry, there's not loads of space. Do it a bit better though. Better. Brilliant. Right, now I'm going to complete the square. It's going to be x plus 1 all squared. That'll give me my 2x. I need to then minus 1 squared, which is just 1, still -15. And that's going to give me, sorry, I'm going to have to write it up here, x plus 1 squared minus 16. I'm going to get a turning point of -1, -16. Notice that x value is in between -5 and 3. I don't have to substitute -1 back into my original quadratic now. I've got it from completing the square. So if I want to sketch this quadratic, let me draw the axes a little bit better actually. It's only a sketch, it doesn't have to be perfect. The main thing is labeling it. So I've got my x-intercept at -5 and 3. Y-intercept at, where was it? It was -15. I'm going to draw the curve. I can see that it's going to be going down a bit further over here. And I'll just add that turning point on, which I need to write as full-on coordinates, -1, -16. Okay, it's in quite a small space to draw that, but I hope you can read that and it makes sense. That should have been a 3 there. But you can see how actually completing the square is a more powerful way of finding the turning point. Here the quadratic factorizes, but not all quadratics factorize. Next lesson, we're going to look at why completing the square really comes into its own there. I'd like you to try this one on the right yourselves. I'm going to talk through it. So y equals, it's going to be 6 and 4 plus 6, x minus 4. So I'm going to jump straight to the intercepts. The y-intercept is going to be minus 24. The x is going to be minus 6 and 4. Let's complete the square. Back to this one. Very similar, in fact. It's going to be x plus 1 squared minus 1 minus 24, which gives me x plus 1 squared minus 25. Turning point is then going to be minus 1 minus 25. So the sketch I've got minus 6 and 4. I've got minus 24. I can see that the minimum is going to be this side again. So actually I'm going to first of all draw my sketch. It's a happy quadratic again. This is going to be minus 25. Sorry, minus 24. And this point here, my turning point, is going to be minus 1. It all makes sense, like it's in the right place and everything. Okay, that is a solid sketch of a quadratic, and it's quicker. Now we can complete the square. So this is over to you now. We're bringing in all the skills of recent lessons. Can you fill in, actually there's 2 grids, but here's the first one. When I give you the quadratic, can you factorize it? Can you complete the square? Can you find the intercepts? Can you find the turning point? Can you sketch it? What if I gave you the sketch to start with? Can you work backwards? They're all in this form, x squared plus bx plus c. There's another sheet to show you, but try this one first. See if you can manage it. Hopefully you can. Hopefully you're able to expand, factorize, complete the square, and interpret these things at this point. Give it your best shot. I'm going to show you the answers. Here we go. Okay, I'm not going to talk about them loads. We've got these different special cases, difference of 2 squares, one without a number in. Get all these different quadratics, make sure they look roughly correct. And if you've done that, here's a slightly more challenging sheet. But along similar lines, but worth practicing. And here are the answers. So for the very last one, there's actually absolutely loads of quadratics that have a y-intercept of 0, 5. That's kind of the point of the question, as long as c is equal to 5. And here they've thrown in a negative quadratic, which we'll be talking about more, but if you managed to do that one, well done. This one doesn't factorize, so actually it's a good example of when we wouldn't have been able to find the minimum point using our previous methods, but with completing the square you can still get there, minus 3 and 4. So there's a lot going on with quadratics. Well done on your efforts. We are going to be moving on with completing the square, so make sure that you've got your head around this. Okay, rewatch if you need to, and you'll be ready for more next time. Thank you.